Okay, let's get started here. I just hit record on my side. I've never actually recorded and tried to post anything before, so hopefully this will work out okay. Because yeah, there's a few people that have already pinged me saying they won't be able to make it today, but they want the recording. So I'm recording right now, and I'll hopefully be able to post it to the course site. So this will be our first homework help session. Kind of the idea came from one of your classmates last week had a lot of questions on homework too, and so I met with her in person or over Zoom, and she had a lot of questions, and we thought it might be helpful to do this every week for just anybody who was interested. So it's kind of what we're doing here, and so I'll let you guys decide how we want to do this. I thought we would focus on assignment 3 since that's what's due this week, and you guys could ask questions about that. And if nobody has any questions on assignment 3, we can go back and look at one or two assignments, 1 or 2. Does that sound good? Does anybody have any questions? Or I can just start going over assignment 3 if you want. If you don't have any specific questions, I can just go over number 3.
Hi, Dr. Hodge. This is Sharice Rich. I do have a question on assignment 3.
Great. What's your specific question you got?
My specific question is, I ran my data, and what if the coefficient in the R squared does not match my linear equation?
Okay, let's pull it up and take a look.
Thank you.
Yeah, that's fine. Okay. Trying to keep an eye on students joining so I can admit them to the room. If you see somebody just waiting there, I don't know if you guys can tell, just let me know. I don't want people hanging out. Okay, you guys can see my screen?
Yes, I can.
Okay. So let's see here. So assignment 3. So you were saying that your linear regression equation didn't have the right coefficients, or you were getting something different? Is that what I'm hearing?
That is correct.
Okay. Was that for number 1 or number 2?
For number 1A.
Okay. Okay. Yeah, that's a good one. Let's just work through that together then.
Thank you. Actually, I'm at work, so I'll just take notes, and I don't have my computer right in front of me. I do apologize. I thought the meeting was tomorrow.
Oh yeah, no worries. I'll just walk through it then, and if you have any questions.
Thank you so much.
Yeah. So I went through and I solved these already. So I'm going to just start working from that because I have a lot of screenshots and what have you here. This isn't visible to the students. I can make it visible once the assignment is due. I just want people to be able to copy it. It's opening up. Just getting set up here. Okay, so then assignment 3. Let's get the data. Okay, so here's our data. So we've got a few different columns here. You should look familiar. I think these were from the past assignment as well. And then we just have the keys for what the numbers mean. And then the question for the homework for 1A says, so we want to make how would you rate your health as our dependent variable. So if you went through this module's lecture, there are a few readings and a few videos that talked about independent versus dependent variable. The dependent variable is what we want to predict. So we're trying to predict if there's any relationship or if there's a relationship, how can we predict a future value of how you would rate your health score? And then we're going to compare that against this one isn't even asking us to compare it yet. Oh yeah, it is right there, exercise. Okay. So we want to compare that with exercise as our dependent variable. And then let's see, we're going to show our results and then interpret them. Okay. So our dependent is your health scale, and then exercise is your independent. So first you got to make sure you have in your Excel, you've done the work that you need to do to install the data analysis pack. If you haven't done that, you're gonna have to go do a little bit of Googling, I think, because we're gonna need that for our linear regressions that we're gonna do. So this first one we're doing, this all number one, it's a single regression or simple linear regression. And so to do that, we click on data analysis. We're gonna wanna find regression, which is this right here. Say okay. Open my, this is my my answer key over here. I'm just trying to follow along, make sure I don't skip a step here. Okay, so we want to put our rate our health as our Y variable and exercise as our X variable. So rate your health is going to be this guy. We're just going to click on that box so we can go pick all of these. And then what was the other one? Exercise. There we go. So I just sort of cheated a little bit there. It's saying I'm taking all of the F column from row 1 to row 311, just because I know that's how many there are. And I have to go drag it all the way down. And then I'm just going to say that there's labels there so that when I do run my analysis, it'll pick up the label on row 1 and make it a little bit nicer output. That's really all I have to do so far. So I'm just saying what my independent and dependent variables are. I said E and F are my columns I'm choosing right there. Switch over here to my Word document just to show you. So it should match just like this. It looks like it is, except I didn't use the labels on that one, but I am here on this one. And then if I hit OK, it's going to go create a new worksheet with our answers on it. So it's going to output something like this. And so there's a few things that we want to look at for the specific question that we're working on right here. The first one, we kind of care about the p-values. Make that column a little bit bigger. So we're going to care about the intercept and the p-values. So let me highlight those. So we care about that. We care about our p-value. And then we care about this coefficient right here in terms of your question about making the equation. Let me scroll down and see if I'm missing anything. Yeah. So the first thing we need to do is make sure that the variable that we're trying to use, which is exercise, to predict our health score, that we have a p-value less than 0.05. That's letting us know that there's some sort of significance there in the data, and it's something that we can find a relationship between. And so as long as this number in the p-value is less than 0.05, then we're okay to use it, and there's some sort of association there. And this number is 0.02 is less than 0.05. So we can see that there is some sort of link between exercise and our health rated score. So we're okay to use that. And so then to write our equation, which was your specific question, it is, the notation is B0 plus B1 times X. And so if we fill that out, our equation for our line, so B0 is going to be the intercept. So it's 82.4614. And that number is, trying to find my other Excel sheet. It's this one right here, the self-rated score. So we're saying we can calculate or we can predict a future number based off we'll start with 82.416, and then we would add on this coefficient 0.763303 times whatever their exercise score was. So it would be an equation similar to this. So if someone were to say, I have an exercise score of 5, which what is that? I don't even know. Exercise score of 5. So if someone exercises every day, we could say they have 82.4614. Sorry, I'm going to fix this. This one right here isn't quite right. I did equal sign, but it should be a plus. Plus 0.76330. 3 times 5. So it would be something similar to that. And then we could actually calculate what that is. Like that. So if someone who didn't exercise at all, we would expect their health score to be an 82.4. And if they exercise 5 times a week, we would predict or assume that it's going to be about an 86.27. Just want to make sure I got that right. Yeah, it's the same thing. So that's what I would put for 1A. Do you have any disagreements or issues with that? Or is there anything that got caught up on? Doesn't make sense?
No, thank you so much. It better explain it once you showed me how to do it. I was actually looking at the Excel video that was in our module, and I was following that one for the linear regression, but this is great. So thank you so much for your help on that.
Of course. And then just looking ahead, I guess we can just keep on going ahead with this. Let's see. So it says, what is the coefficient of the exercise variable? That was right here. That's that 0.76. What does it mean? And then what's the p-value? So the p-value is this one. It's a significant thing. And then they're saying, what does this coefficient mean? And it's saying for each 1 unit or 1 number increase in the exercise score, your y-axis will go up by a 0.716. I don't have a graph here, but if you did, you'd see a slight line going up. It would cross the y at 82.4. It's going to take a lot of work to draw a graph, so I'll just try to describe it. But if you picture an XY graph, there's going to be a line that crosses the y-intercept at 82.4, and it's going to be slightly up. So for each unit over in x, it's the line is going to go up 0.76 units. And that line is a trend line. That's what we're trying to do. This whole linear regression assignment, the whole thing that we're trying to do is create a linear regression line. And so on a graph, we're going to put a lot of dots. We're going to put our exercise dots, which is this variable, and we're going to put our exercise score, which is the variable we're trying to predict. We're going to plot all those dots. And the linear regression just drawn a line, a straight line, no curves. And it's going to say, where does it cross the y-axis? And then where does it keep going forward? And the whole idea is that we can use that line now, this equation that we just came up with, to predict things into the future for data that doesn't exist. So we could say, if we added on maybe an exercise score of a 6 or a 7, which are even more frequent, which don't exist in this data, then we could predict what their rating scores would be, which would be, I don't know, like 70 or 87, 88, 89, something like that. So that's the whole idea of what we're trying to do with linear regressions. Yeah, so this next one is the same thing, but we're just using education. It's literally the exact same thing. So we're keeping the dependent variable is our health rating score, and then education is the next one. So we can do that really quick. I'm just going to delete that sheet, so we're starting over. So we just go to data analysis, regression. So it is remembered where we left off. So we're going to keep that one, and we're changing this one. So we're changing it to education, which are these ones. Got our labels, going to a new workbook. Same thing here. So the difference here, so this one's an interesting one. Let me expand to that. So again, we care about the coefficient and the intercept and our p-value. Highlight those. And so we had said that our p-value needs to be less than 0.05, which this is not. So we would stop right there. We wouldn't do anything else. There's nothing we can, there's no association between education level and our health scores. I just want to check my sheet to make sure I didn't mess that up. Yeah. So we can't make any assumptions. We would just stop right there. If it's not less than 0.05, then there's no link there. So that would be the answer for B. Just stop right there and you're done with it. And let's look at C while we're on a roll here. So it looks like same thing with our health score and then BMI. Okay, so let's go do that really quick. BMI is column A, all the way to the end. Okay, so again, we care about the coefficient, the intercept, and our p-value. And so this number is less than 0.05. So this is, there is an association, it's significant, and we can make a prediction based off of this thing. And so the equation for this line, this regression line would be 89.66248 plus minus 0.17229 times whatever your BMI score is. And this one actually makes sense. So this one's a little bit different. It's a negative number. Our coefficient is negative. And so this is saying for each increase or each step of a BMI. So if you go from a BMI, say like from a 25 to a 26. So for each 1 unit increase, our health score is going to go down by 0.17. And that makes sense. So we're going to have a line that slopes down from left to right. It's going to go down. That's just saying for the heavier or higher our BMI score is, the lower our overall health score will be, which holds water. I guess it makes sense logically. Let's see if that's what I got here. Yeah. Yeah. Do you guys have any questions about that? So we just did one A, B, and C quickly.
Thank you again. It makes a whole lot of sense now. Thanks.
Yeah, happy to do that. Does anybody else on the call have any questions about this?
I have a question about number 2. Can we run through that one as well?
Of course.
Also, I got the linear regression part, but when it came to answering the questions was.
Yeah, so number 2 is a little bit different because we're doing a multiple variables here. I believe, let me read this again. Yeah. So yeah, so we're gonna do a multiple regression on this one. So it's a little bit different. So we're doing future health is what we want to be able to predict. And we're gonna see if there's any relationship of future health and BMI, future health and age, future health and education, future health and exercise, and so on. So these are all the things we're interested in seeing if we can use to help predict future health. Okay, yeah. So there's just a couple of weird things that you have to do to make that happen. So let's delete this. So the way that this data analysis tool will work to do multiple regression is we're going to need to put all of our data together. It doesn't let us flip all of our or select columns individually when we're trying to do a multiple regression like this. So we have to place them all close together. And however you want to do that, there's no wrong answer, but to be fast, I'm just going to copy into a new sheet. So we've got age, education, exercise. Age and education. Oops. Let's see. So age, education. Exercise. Oh, and then rate your health. Okay. And then rate your health. Okay, so now we just have the data that we care about, and they're all in a row. Shorter name. Okay. And so what are we trying to do here? We're using BMIs are dependent. No, future health. Okay. I think I missed that then. Future health. Okay. So now we can do our data analysis, do a regression. Okay. And then for these ones, so this is where it's slightly different. And so for our ones we're predicting, we have to select all of them like this. It's just one big box. And then it knows how to parse these out by column and row. There we go. Oops, too far. Okay. And then when I did that, it automatically created this bad boy here. So there's a couple of things to look at, or it's going to look slightly different. So let me just point out a couple of things. Let me highlight all the stuff that matters. Okay, so there's a few things to talk about here. So the first thing we can look at is when we're running multiple regressions at the same time, there's this F test that we can look at, and it's telling us if this number is less than 0.05, then it's saying at least one of these variables, independent variables, has significance. And so as long as this number is less than 0.05, we can continue on looking down here. And this number is way smaller. If you're not familiar with scientific notation, what that's telling us is it's equal to saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 1, 8, 6, 3, 2, 1. So it's saying that this is the number. Oops, it converted to scientific notation. So it's way smaller than 0.05. So that's good. So we'll go ahead and continue on with this. And then we got to look to see which ones are actually less than 0.05. This one is not. So let's get rid of it. This one is not. This one is not. So none of those are significant. We don't care about those. So that means they don't do anything to help us predict our variable. And so then these three do. And so we would need to talk about them specifically. And I'm just going to bring up my Word document for it. Scroll down here. Yeah. So then you would just do the exact same thing that we did before. So for example, age is the first one on that picture here and on my spreadsheet there. And you would write the equation just like this, like we did before, right? So this is the intercept minus 0.14675. And then we would look at the coefficient here just for age, which is so 0.00642. So this would sort of be the equation there. Or if you wanted to put it in layman's terms, it's right here. For every 1 year in age increase, your future health would decrease by 0.006 units, whatever these units are. And then you would just do that for the other two, right? So we have age is interesting or important. Exercise likewise is interesting. And then our self-rated health. And you could write those equations for those other two variables right there. Make sure I covered all that. Yeah, so it's just those three that are significant. And that was how you would interpret those, just these right here. Or whatever, you just put it in some sort of English words, however it makes sense to you. Okay, and then let's see, 2b. Okay, yeah, so r squared, we didn't look at that. So r squared, I highlighted these here. There's two of them here. There's r squared and adjusted r squared. I guess it's only asking about r squared, so I won't talk about the other one. But r squared, what that number tells us is that we are able to predict accurately about 25, or I should say, these dependent variables, these independent variables we're using down here, the BMI, age, education, exercise, and what have you. Those 5 variables combined are only able to actually accurately predict what are we predicting? Our health score. This model is accounting for only about 24% of the variation. So we're only about 24% accurate. So our score it's a pretty low number. It's saying is that this model that we're using is only accounting for like 24% of the variability within our data. And so we're only about 24% accurate with our predictions. And so there's a couple of things you could do if you actually cared. It's not a part of the assignment, but you can see that BMI and education weren't contributing to this model. So we could take out BMI and take out education and rerun this scenario. And it would probably go up a little bit, maybe to like 0.3. It'd be a little bit more accurate because those two are sort of weighing things down. They're not helping much. But what it's telling us is there's not a huge amount of predictive ability with these numbers for what we're trying to do. It's only accounting for 24% of what we would want to see in our model here. So it's kind of what the R-square is telling us. You want a higher number, like obviously 1 would be perfect, which is not really realistic. But anywhere over like 6 or 7, or I should say 0.6, 0.7, 0.8, something like that. Those are really good predictors. So this is really low predictors. Oh yeah. So saying, how does that compare to the ones which I deleted, but I have it here in my worksheet here. So you see we're accounting for 23% of variability with our model here when we're trying to predict that. But if you look at our previous ones, they're going to be even way worse, right? So we have a 0.01. So let's say we're accounting for 1.5% in that case, which is pretty bad. This is even smaller. This is like 0.0005. Yeah, and this is 0.01, so 1.6%. So overall, they're pretty bad, I think is what we're saying, is these numbers, even though there's significance between them, they're not really doing a good job of predicting anything into the future. Looks like I answered all of 2A and 2B. Did I miss something? Do you have questions about anything that I just showed you there? And I didn't answer number 3. I'm just going to leave that up to you guys to figure out. Why do we have regression and if it's useful? It's more of an essay question, not looking for anything too groundbreaking there, just to make sure you understand what regression is. Questions? If not, that's all of assignment 3.
Hey, Dr. Hodge, this is Sabrina. Thank you so much for helping explain assignment 3. I had some questions about assignment 2.
Okay.
And since it hasn't been graded yet, I was just wondering if I did it in the right way. Specifically, like number 1 wasn't really hard to interpret, but number 2, I wanted to make sure I was interpreting that the right way. The what % of the population have a university education or are under the age of 30?
Yeah, that's probably the number 1 question I got from students and emails was this number 2 here. It is pretty ambiguous. So I took it so I didn't write this question. This comes from Jessica Ryan. If any of you know her, she wrote this assignment. And so I'm taking it at face value. And so it's saying, or, right? So either you have a university education or you're under 30. Because the other one, she's pretty clear about it being and. So I just want to make, yeah. So I guess really any way you tackled this would be fine. Let me go see what the answer she put for number 2 was. Oh, it's kind of hard to read how she did this. I might have to get back to you, but it looks like right here, she came up with the number 150.
Okay, yeah, so 48% or 48.4 it says, but I put 48%. So I
Okay.
guess,
Close enough, yeah.
yeah, because that was really confusing to me just because like I used the COUNTIFs formula.
Mhm.
and
Yeah, that's what I would do.
basically- Yeah, I had to put in both COUNTIFs and then subtract the COUNTIFs that if they were, I don't know. It was really complicated, but I guess I got it. So
Yeah, that's exactly what I would have done.
okay, yeah, that's why I just want to make sure. I didn't know if there was an easier way to do it than what I did, but
So there's the 2 choices. I just want to make sure what you're saying, because there's the count if, which counts one thing, or there's the count ifs with the S on the end, and I'll let you count multiple things at once, and it merges them together. Is that what you did?
yeah, it was the COUNTIFs.
Yeah, that would be the easiest way.
Okay.
Yeah, and then you would have to know what the total was and sort of do a division to find the percentage. Yeah, and it sounds like you did that. You got 48.
Yes.
Yep.
Okay.
So sounds like you did right. Do you have another question on assignment 2? Or does anybody else on the chat? Well,
Hi, I was wondering if we could if you could upload the answers to number 2 so we could check it.
yeah. As soon as I finished all the grading, I was going to turn these answer keys on.
Ooh, awesome. Thank you.
You bet. Were there other questions for anybody else on the call?
I have a question about the exam. How is it going to be set up?
Let's go see. So is this what you wanted to know specifically? So it says we got 45 minutes. It's going to be in the lockdown browser. It's worth 50 points.
Okay, is it going to be open note or anything?
Oh, I see what you're saying. Yeah. So it's in the lockdown browser just to make sure you're not working with classmates, that it's you doing your work alone. But you can use notes and you can use your textbook. You can use the internet. You can use your calculator. It's not trying to trick you. We're just trying to make sure you're doing your own work by yourself.
Okay, and kind of like, not a specific question, but how are they gonna kind of be worded since we've worked through Excel with all of our homework?
Hang on, I'm going to take this off screen where you can't see it, and then I'm going to open the questions. Okay, so it looks like we only have 4 questions on here, and they're, looks like they're, oops, hold on. There we go. Okay, yeah, so they're going to be essay questions. Sorry, I hadn't looked at this yet, so I wasn't quite prepared to talk about it. Let's see. Okay, so we're gonna give you some sample data, and then just it's gonna be more about concepts than anything. So I think I actually sent out an announcement, or maybe to someone's email. They are asking about a study guide for the midterm exam.
Yeah, no, you sent a list of things to study.
Okay, yeah. So I think as long as you know those basic concepts and how they relate, then you'll be able to answer these questions. The exam is putting them into context of a specific scenario. So like question 1, it says a hospital administrator is looking at the length of stay for patients with COVID-19. And then it's going to ask you questions about that having to do with those concepts that we talked about, mean, median, mode, p-value, significance, stuff like that. So it's more specific, but as long as you know those basic concepts,
Okay.
shouldn't have much of an issue.
Oh, look.
Okay, perfect. Thank you.
Yeah. So I don't think this first one is looking for specific numbers or specific Excel formulas. It's more concept based. I'm just reading the other questions to make sure that's true. Yeah. And then there's a question here about study design, like cause and effect. So there's a couple of videos and a couple of readings about cause and effect and study design. And so just making sure you've perused through that a little bit. And then the last question is about linear regression, which is what this assignment 3 was on. So if you understand what you're seeing on assignment 3, you shouldn't have, again, much of an issue with this. Yeah, so I guess that's about as specific as I can be without giving you the actual questions. Do you have other questions about the midterm, or does anybody else?
I don't have any more. Well, or I guess one of the sessions, will we be able to kind of, well, I guess we don't really have to review because you already gave us the study guide, so never mind.
No, we can. We're going to be doing this meeting every week. As long as people show up and have questions, we can review the midterm next week or whenever after it's due, I should say.
Okay, perfect.
Yeah. That's all I have, unless you guys have other questions for me. Okay. Well, that's easy then. So I'll try to find a way to post this recording, and then we will try to meet. I don't know if it's next week. Let me pull it up. March 10th. So I think that's a Wednesday. So we'll meet March 10th at the same time.
Thank you so much for taking the time out to do this, Dr. Hodge. It's greatly appreciated.
Yeah, happy to do it. Okay, guys, have a good week.